All right, guys, today is 11:05. This marks the last section of notes we'll have for Algebra 1 honors this year. Today we're going to talk about choosing a data display. We have two different types of data that we're going to learn to display. The first type of data is known as qualitative or categorical data. This consists of labels or non-numerical entries, whereas quantitative data consists of numbers that represent numerical counts or measurements. All right, so let's just get a little practice with that. Tell whether the data are qualitative / categorical or quantitative. Prices of used cars at a dealership. All right, so we're talking about some numbers here that we can compare. This is going to be quantitative. Wow, let's see if I can spell it right. Yeah, quantitative. All right, next up we have letter B here, jersey numbers for a basketball team. Now this is a little bit tricky because numbers, it says here, are numbers, and you would think, hey, maybe that's quantitative, but you really can't compare these. So maybe this is more categorical / qualitative. Oh, let's see here. Big words, tough to spell. All right, how about lengths of songs played at a concert? Now, these numbers actually can be compared. So we're going to say that these are quantitative. And then finally, zodiac signs of students in your class. So these are definitely categorical or qualitative. We'll go with the word qualitative here. All right, next up, let's talk about the different displays that we can choose based on the data that we're trying to display. So we have different types here, whether it's a qualitative categorical or quantitative. A best form of display for qualitative categorical data would be a pie chart, a bar graph, a two-way table, or a segmented bar graph. Now, some of these say one variable, two variables. So, so far we've really kind of just been looking at like this one variable statistic stuff. So pie charts or a circle graph, bar graph would be your best way. We have done a little bit of two-way tables looking at frequencies of a couple of different variables like freshman, sophomore versus ridden an electric bike or not ridden an electric bike. All right, other forms here that we can choose when we have a quantitative data set would be box and whisker plots. We've looked at lots of those. Histogram, we've done a few of those as well, and dot plots. For two variable types of statistics here, we'd get into a line graph or a scatter plot. All right, let's take a look and just see if we can determine what type of data we're looking at and what would be the best display. Example 2 says you have letter A, gives you the eye color survey. You have different eye colors, brown, blue, hazel, green, gray, and amber. All right, and all these different frequencies of students that have responded to that. Well, first of all, we should start off by labeling this as categorical. This is definitely categorical data. It's not quantitative. So under the categorical, you've got a couple of different choices to choose from. And I would say that the pie chart or the circle graph there would be your best bet. That way, you are going to see what percentages look like compared to the whole. Next up, you've got these speeds of vehicles, and it looks like you have two different interstates that they're comparing. So here, we're comparing quantitative data. All right, now quantitative data can be compared maybe in back-to-back histograms, maybe even in some side-by-side dot plots, but probably the best way of doing this one would be the two comparative box and whiskers. All right, so when we see that box and whiskers plot side by side, we'll be able to see the range, we'll be able to see the median speeds, we'll be able to see that interquartile range and how they compare to each other. And that gives us a nice visual of that data. All right, now graphs can be misleading. So what are some things that we should be looking for if a graph is misleading? First of all, a misleading graph is a graph that's not drawn appropriately. It may be mislabeled, and it can really cause you to misinterpret the data. All right, so here are some questions to ask yourself when analyzing statistical graphs to help you recognize when they're misleading. Does the graph have a title? We're going to want to know what those statistics, what that data represents. Are the numbers on the scale evenly spaced? Does the scale begin at 0? If not, is there a break in that axis? Other questions are to consider are, does the graph need a key? In other words, how to read each of the data points. Are the axes or sections of the graph labeled? And then finally, are all the components of the graph, such as the bars, the same size? So example 3 just asks you to consider these misleading graphs and explain how someone might misinterpret the graph. All right, taking a look at the letter A, you've got tuition, room, and board at all colleges and universities. You've got average cost in dollars on your vertical axis and your academic year here on your horizontal axis. Well, everything seems to be labeled pretty well. It looks like we have some evenly spaced axes here, right? We go up by calendar years. So the only thing I can really see here is it looks like my vertical axis doesn't start at 0. So that's one thing I'm going to note. Vertical axis doesn't start at 0. Now, what can this do? What kind of effect can this have on interpreting or misrepresenting the data here? So really what this looks like, I mean, you could look at the 2012, 2013 year and then say, man, your tuition, room, and board at college universities doubled going from 2012 to 2015, because this bar here looks like it's about half the size of the bar from 2015 to 2016. So it might cause you to misinterpret how quickly these costs are increasing, when in reality, if you look at the axis, it looks like maybe it only increased about $2,000. So that's what you're going to want to write in here. I said it out loud, so maybe pause the video, go back, and write out that misinterpretation. All right, let's take a look at our line graph here in example B. Looks like we have the mean hourly wage for employees at a fast food restaurant, the wage in dollars per hour. All right, and then you got your calendar years here on your x-axis. So again, it looks like everything looks pretty good here. There's a break in my my vertical axis, so that's good. It's showing me that I'm kind of jumping up here and starting at $8.90 rather than starting at 0. So that's good. However, if I look at my vertical axis, it looks like I jump up by some different increments from $8.90 to $92 to $94 to $96, $98 to $9, but then I go up by a penny. Here's 901, 902, 903, 904, 905. So this piece here is a little bit misrepresented in the way that my vertical axis is not evenly spaced. All right, now what this could do in terms of misrepresentation or misinterpretation, you might look at this and say, oh, there was the greatest rate of increase between 2018 and 2019. It went up really quickly here. However, it's actually only going up by 4 cents because I'm going from $9 to $9.04. And maybe the greatest increase is really from 2016 to 2017, because it looks like here I'm going up from like $8.93 all the way up to $8.98. So that represents a 5-cent increase, whereas this guy here only represents a 4-cent increase. And that's a clear misrepresentation of the data. So again, pause the video, take some time to write down how you could misinterpret that based on these unevenly spaced axes.